Rope used for rescue, rope access, or work at height should be specifically designed and intended for life safety use, and it should be tested and marked in accordance with a relevant standard. Well, this begs the question, what is a relevant standard? I mean, there are actually several standards for life safety rope around the world. Are they all the same? Well, the simple answer to this question is no. They are not all the same. In the United States, the most respected life safety rope standards like NFPA 2500, ANSI Z359, ANSI Z459, these all refer back to Cordage Institute life safety rope test methods. Now, one of the things that makes the Cordage Institute life safety rope standard unique is how it specifies reporting of minimum breaking strength. Specifically, the Cordage Institute sets a process of deriving minimum breaking strength from testing at least 5 samples of rope to failure and then calculating 3 standard deviations below the mean of those results. Now, this is important, and we're going to talk about why that is. So, say we submit several samples of rope to a test lab from 5 different lots of rope. Their job is to pull test the rope to failure. Even if they precondition the ropes and use the same exact test method to pull all 5 samples, and they should, they're still going to get slightly different test results with every test. That's just a simple fact in materials science. Not every sample is going to test exactly the same. There's going to be some natural variation or difference between each sample. Although we do expect the test results to be more or less in the same ballpark, there are going to be differences. So even so, with 5 different numbers to work with, or 10 or 20, or however many we decide to test, what's the right number to report as the reported minimum breaking strength of the rope? Let's look at some actual numbers so that we can maybe make some more sense of this. Say we do some testing of 5 samples of rope. One of those ropes is going to break at, say, 6,500 pounds. Say another breaks at 6,750 pounds, one breaks at 6,675 pounds, maybe one breaks at 7,005 pounds. And we have one more, so let's say it breaks at 6,925 pounds. 5 different numbers. What do we report? Well, I can tell you the manufacturer's marketing department is going to want to report the best result, which in this group of tests was when the rope broke at 7,005 pounds force. But as a competent or qualified person working in the field, I don't really care about your marketing. I'm really more interested in a worst-case scenario for calculating system safety factors. Our worst test in this case, we said, was 6,500 pounds, which was about 500 pounds less than our best result. But we've already talked about the fact that there's always going to be natural variation in materials testing, so philosophically speaking, what if all 5 samples I just tested just happened to be from really good, consistent batch or batches of ropes? Even if I use the lowest of those test results that I got in that series of testing, can I rely on all tests of that make and model of rope being at least that strong? How can I even know? What should we report? That's why the Cordage Institute test method and NFPA, ANSI, and other standards that refer back to it use this mathematical approach to help ensure that the number we report is at least somewhat statistically significant, and that the rope that you receive as a user is at least as strong as the advertised minimum breaking strength. Other worldwide standards, like the Euro norms or CE standards, they don't use this method. The only way to get this level of reliability in reporting is to use standards that refer back to Cordage Institute life safety test methods. The method used by Cordage Institute life safety rope standards is referred to as the 3 sigma minimum breaking strength, or 3 SigmaMBS method. And here's how it works. We make at least 5 tests on ropes from different manufacturing lots using a very specific test method. Then we calculate the mean average of those results, and we subtract 3 standard deviations from that number. Using that method, we can deduce that 99.7% of all possible results will be at least that strong. Let's see what that looks like on a practical level using our sample set. First, we add up the sum of all of our test results. Then we divide by the number of tests to get a mean average. In this case, the sum of the 5 tests is 33,855. Let's divide that by 5, the number of tests, to get the average, which in this case is 6,771. Then we're going to use a standard mathematical formula to figure out how far each test result varies from the average. Then we average that number. So now we can say that the average variation from the mean average is a little over 200 pounds. We call this the standard deviation, and it's represented by this little symbol called a sigma. Then, just to be very sure that we're being super conservative, we multiply that standard deviation by 3. So 3 times 200.98 is 602.94. We refer to this as 3 sigma. Now let's subtract that 3 sigma number from the mean average that we got in our first step. So let's go back using our example, and the mean average was 6,771. Let's subtract our 3 sigma result, which is 602.94. And we're going to get a result of about 6,168. That's a full 900 pounds less than the best test. And it's 332 pounds lower than even the worst test. In other words, we're talking 2 to 3 body weights in difference. Is this going to affect your safety factor calculations? Well, heck yeah, it is. The 3 sigma minimum breaking strength is a number that you, as a competent person, can rely on. You can know with 99.7% confidence that any rope you're using will be at least as strong as the 3 sigma result required by Cordage Institute test methods. As a rope technician, when you're looking at safety factors in your rigging, isn't it comforting to know that you can have confidence in the rated breaking strength of the equipment you're using? And to answer the question that I'm asked almost weekly, no, not all standards use this method. Actually, even within Cordage Institute, the life safety rope standard is the only standard that is this robust. In fact, many standards don't even specify how a reported breaking strength is supposed to be derived. They say only that the strength of tested samples needs to be greater than some baseline figure, usually a magic 5,000 pounds, which is a topic for another presentation. Anyway, that's all for now. So how do you use MBS figures on your equipment? Is this figure important to you from a safety perspective? Drop us a note. Let us know what you think. And please keep those questions coming, and stay tuned to PMI for more practical technical rope rigging information that you can use.